here for fire engineering. Hey, thanks for tuning in with us today. Great group of guys from the UL laboratories are with us today. Fire safety science guys, as everybody knows them, and they're going to be talking to us today about the latest round of experiments and research that they just finished conducting. They just wrapped up on, I think it was March the 18th was the last burn that Steve conducted out there with Danny and Robin and the gang. So we've got a bunch of really smart guys that Steve's put together and Robin's put together to visit with us today about what was going on out there, how they put them together, why they chose the buildings they chose, what kind of experiments they put the thing through. But before we begin, we want to give a shameless plug out to FDIC, which is 20 days away, and Robin's going to be doing a great class there, and I'm going to ask him to talk a little bit more about that. Where he's going to be talking, it's called "What About the Victim?" or customer, depending on your vernacular. A really important workshop. Steve is also doing a workshop and a couple of other sessions. We're always going to, as usual, we'll have science in the big room. But Steve and Dan and Robin are also going to be talking about the burns we did out there last year and some of the results from that and how they were collected, and really exciting stuff and important. It's not only important to hear about how they conducted the experiments, but it's also important, and Steve's going to talk to it today, about how they analyze the data and then how they disseminate the data out to people for further analysis in regards to tactics, which is really kind of a critical deal. You know, we watch the videos and we all, take away what we want to take away from it, but they go much further into the actual physical science of fire behavior and gas production and flow paths and heat flux and all the other issues that they then compile to get us that real in-depth picture of what was going on versus the, just the kind of two-dimensional picture we get when we're looking at a video. So we'll get into that. But we're 20 days away. Hot classes still have a few spots left open, but pretty much sold out. Few spots left open in bailout, which is a great class. Some spots left in our farm machinery extrication class, which is kind of important for a lot of firefighters. Unique extrication opportunities. Main program this year is going to be spectacular. We've got Steve Pegram. Steve has an incredible story to tell from a professional and from a personal standpoint. So you really want to hear Steve's story. It's just unbelievable. He's the president of the International Society of Fire Service Instructors. He's an incredible gentleman. He's the chief of the, and I always get it wrong, Goshen Fire Department. And then on Thursday, we have our dear friend Derek Alconis, and Derek's going to be giving a brilliant motivational talk that he's put together. And if you've never heard Chief Alconis speak, he's one of the most dignified individuals you'll ever get to listen to. He's eloquent, he's dignified, he's insightful, he's just a wonderful person, and he's going to share a really deep message about firefighting and about our role in our communities, and about the work we're doing today and how we interact with one another. So you really don't want to miss that. Hundreds and hundreds of classrooms, 211 classes going on, everything from soup to nuts. We've got folks coming in to teach from Australia, Japan, Chile, so it's going to be really, really neat. Please sign up for the stair climb, the NFFF stair climb. Please sign up for the fun run. Please come to the comedy night to support the Cancer Support Network, Stop, Drop, Rock and Roll, the Union Night, the Fool's Bash. There's something happening every night. It's a neat thing. I'm so grateful to be allowed to participate and still go. It's humbling to be a small part of what happens there every year, and to be allowed to participate is I'm so thankful for the opportunity. I'm so thankful for, while I have a chance, I'm so thankful to my good friends at UL. If you haven't been to the Firefighter Safety Research site, and if you haven't taken a look at the work there on the floors, on the collapse times, if you haven't taken a look at the wind-driven stuff, please take the time. Go through the classes that Steve and Robin and Dan have put together with Julie. Julie's the course designer, one of the unsung heroes. She's probably one of the most brilliant course designers you're ever going to want to see. The educational opportunities that are afforded for you on that site for free are second to none. And please check out the fire behavior site that Brian Kazmarek is putting out there, the modern fire behavior. There's tons of information there. If you haven't availed yourself of these opportunities, you you're missing out, because it's such great work. It's so deep, and it's so important to understand not only the mission behind it, but the passion. And I'm so grateful as a member of the fire service. I'm currently still a volunteer firefighter. For the work that these men have done and their endless sacrifice that they've done. And if you don't think they haven't sacrificed stuff, you're crazy. I've been with them both while while Steve's children are going through holidays and parties and birthday stuff, and he's out there training and teaching and conducting experiments. Robin's wife had to do house searching and things that we normally do as couples, because he was so dedicated to being where he had to be in the time that Dan spent away from their families. So we really owe them a tremendous debt of gratitude. They're just as dedicated to the mission of the fire services as anybody you've ever heard of, whether you're talking about Leo Stapleton or Chief Brunacini or Chief Clark back in the day. These men and women that are working with UL and NIST and all our other great partners, but particularly this particular group, we owe a tremendous debt of gratitude, and I'll be forever grateful and thankful to them for the work they've done. And with that, Stephen, if you'd introduce the group and give us a little background on the interior-exterior attacks that just were conducted and their relationship to firefighter safety and victim survivability, let's begin the discussion.
Well, my pleasure. We're blessed to be able to work with the best profession in the world, and we're coming off of a busy month, and we talked about sacrifice. The crew that you're looking at here spent just about a month away from home, working 14, 16-hour days to try and pull off a pretty aggressive test schedule, because our technical panel said they wanted 25, 30 experiments, and we had to find a way to fit it in and get it all done, to figure out what we can learn. So pretty much we pulled the Columbia, Maryland office out of their desks and put them in the conference room here. Got Robin Zevotek, which Bobby's talked about, and Robin had the pleasure of running essentially the operations chief role for the experiments that we just did for the fire attack experiments. I've got my attack team here: Keith Stakes, fire protection engineer, as well as a lieutenant with the Bethesda Chevy Chase Rescue Squad here in Maryland. Mike Ault, who had his back on the 30 fire attacks that took place. Mike comes from us with a career background from West Lafayette, Indiana Fire Department, and is really helping us out. Got Jack Regan tucked in the corner over there, who is our, he's been with us for a few years now, his entire way through his education from the University of Illinois as an engineering student there. He's now working on his grad degree at the University of Maryland in fire protection engineering. So we're lucky, so we get him in the office in between classes and in between his time hanging out at the firehouse where he volunteers as well. And then we've got Josh Crandall, who handles everything video. Our experiments have gone from 8 video views with a couple GoPros to 16 video views, 8 GoPros, a drone, helmet cams, you name it. We're trying to capture everything from as many angles as we possibly can, because the fire service is a visual group of people, and we need the visual and IR and everything else to go with the data that we're capturing during these experiments. So we've, like I said, it's been a long month. We're coming off of that, and we're left with a mountain of data and thousands of hours of video that we need to go through to figure out what we actually learned. I think that this is probably our first set of experiments that have, for all intent and purpose, have been covered live on social media. Anything experiment-wise with live footage is nerve-wracking, but I think we embraced it. We tried to get out as much information as possible real time to be as transparent as possible during this entire exercise. I think that that's still a relationship learning thing that we're doing with the fire service, is letting them in behind the scenes to see what's going on, but having them need to help us out and need to understand that the data analysis does not go on real time. The videos out there, our technical panel, made up of 25 firefighters from around the world, came in and visited us during the experiments. They played a phenomenal role of guiding us as we went. Every detail from how the line moves to what details we want to look at, to what variables do the research questions have to answer, to what is the structure, all of those things they develop for us. We run the experiments, and along the way we learn things. We see things that adjustments need to be made real time. We made a few of those with the technical panel pushing us along the way, and they were posting the video real time. Whether it's Twitter, Facebook, you name it, videos were going out. We tried to do our best to try and keep up and get the stuff put out. But as you can imagine, having to run the experiments and make sure everything's good for taking the data, it's not as easy to get the stuff out as easily as holding up a phone and periscoping it out real time during the experiments. But at this point, people have somewhat of a picture of what we did. Now we've got months of figuring out what it all means. We essentially, let's see, how would you describe it, Robin? We've got spreadsheets of numbers that mean nothing at this point.
We just have files of numbers that mean absolutely nothing. They're not even in spreadsheet form yet. They're just lists of numbers. We could print out thousands of pages of numbers. Taking the time to figure out what they all mean, put them all together, sync them up with the video so you can see what's going on at the same point in time you're looking at a piece of data from inside the house. There's a lot of work that goes on there, and it's going to take months, as Steve said, to go through all that, put it in order. Even with some powerful computing programs, it still takes us a very long period of time to get through those, and it still takes a human to look at all the information and interpret what happened.
And we even upped our game this time. We went from 1 measurement per second to 100 measurements per second to catch many of those little minute details that occur with flow and pressure as nozzles are being opened and closed and air is being entrained and movements are being made down the hallway and victim locations are being measured. There was just a little more background as folks want to ask questions. Hashtag FETalk on Twitter. Bobby's keeping an eye on that. But just a little more background. We had a series of experiments that was geared around, a majority of it was interior fire tank, looking at a couple different variables. Nozzle, whether it was a smoothbore nozzle flowing 160 gallons a minute out of a 7/8 inch tip, or whether it was a straight stream out of a combination nozzle, also flowing 160 gallons per minute, straight stream fog pattern, and also how the approach was made to the fire. And the two that the technical panel looked at were essentially a stop and flow, flow and move. So it was water in and periodically opening and closing the nozzle on the way to the fire room. And then there was pretty much hit the hallway, open it up with a wall ceiling wall flow all the way down the hallway to the fire room, extinguishing it. There was one-room fires. There was one-room fires with a vent opposite in the fire room, and then there were two-room fires with a vent opposite each of those rooms. And Keith and Mike were as about repeatable as we could get with accomplishing the attack the same way as dictated by the technical panel that we could every time. We were joking along the way that Keith has now been on the nozzle for more fires in a month than most people have been to in their career. And I don't know if you guys want to share a little bit of your experience of moving down the hall and putting fires out. But a lot of trying to do the same thing over and over again.
It's a lot about repetition. So we started on the exterior of the structure. For most of these fires, the front door started closed. So we got to a certain point in the fire's progression where we opened the front door, at which point us as the attack team took a look at the smoke layer and tried to see where the neutral plane was and see whether or not we could see inside and how far inside we could see. And then we advanced into the building, and we stopped shortly there afterwards and flowed a quick burst of water towards the ceiling to do what many firefighters would call check for return. That was part of our method of the attack. We then approached the corner and started our advance down the hallway. And as Steve mentioned before, we had two types of attack. One we called a shutdown and move, where we started at the end of the hall and flowed water from towards us down towards the end of the hall in a wall-ceiling wall fashion, at which point we stopped and moved forward. Mid-hall did the same thing, and then progressed to the fire room to complete extinguishment. And the other type of attack was to open the line and keep the line open the entire time. And Mike and I had done quite a bit of practicing prior to the experiments itself, and shortly thereafter starting the experiments, we got in quite a good rhythm, and about as good of a backup man as you could have. We did as best we could, and it seemed fairly repeatable, and the technical panel was very happy with how the attacks went. And I was very pleased with it as well.
You did that, Mike?
I was happy to be right there behind Keith, and it was very interesting being able to be at that corner of the hallway where you were still getting some visuals from the front door, and just being able to see. So, you know, he's at the front at the nozzle working his way down the hallway, and I got to stop right there at the end of the hall, and I got to see what differences happened relatively close to the doorway. And it was kind of cool to see some of the differences between flow and move and shutdown and move, fall versus straight versus smooth. It was just neat to be able to be in that position to see some of those changes. So it'll be cool once we get to go through all the video and all the numbers and see maybe some of the things I saw, what they actually were meaning and what they were putting out on data. So
if I could interrupt for a second. Is it okay to interrupt for a second?
Please do.
Well, and I love what Mike just said. As a takeaway for the audience, if you're paying attention, and I know you all are, and we have a few questions I'll hit you with in a second here, Steve and gang, but fascinating comment that Mike just commenting on working with Keith in the hallway. Listen to his words. It was great to watch and see what was happening. That's the role of the officer. And when we talk about the need for staffing, oftentimes it's difficult for us to articulate to our city managers and the people who are holding the purse strings, so to speak, as to why we'd want a firefighter, in particular a well-paid, well-seasoned veteran firefighter who's basically just watching. But if you take what Mike just said, here's a man with, you know, now, as I understand it, Mike was fortunate enough to attend a real university in West Lafayette, Indiana, which I believe, boiler up, is a great place to go to school. I'm just saying that. But if you listen to his words carefully, he was able to watch that fire behavior and see changes and then evaluate, albeit right now just anecdotally and experientially, you know, what was working or what wasn't working. But the same thing could be said for any fire officer in any company, in any town, city, county in our great country. That's their job, is to watch and to pay attention. And here you hear a seasoned and a very bright fire officer saying how exciting that was to do, which shows you two things. As Colonel Hackworth always told us in his wonderful book, the importance of good training, which this really was for Mike and Keith and everyone else who participated, incredible training opportunity, but also an incredible officer development tool as to how to keep your eyes moving, how to keep yourself engaged and aware of what's going on, and then how to evaluate the various tools that are available to us for various types of fires. So thank you for that comment, and really interesting. It'll be very interesting to hear not only what the data tells us, but what Mike and Keith can tell us about how they felt about the shut and move versus the continuous flow and move. And I think that both techniques are very important to master and to be competent with, and both techniques are going to apply to different groups at different times and different fires. But great stuff so far. Why don't we keep going with the rest of the folks there, and then I'll get to some of these questions we got rolling in. We got them rolling in, Steve, on FE Talk.
Yeah, I mean, it's folks that have gone and looked at our Facebook page or Twitter account, UL Firefighter Safety or UL_FSRI for Twitter, can pretty much right now go back and live the series of experiments day by day and get a sense of what occurred. Some of our tech panel members did a good job of giving some more behind-the-scenes information and things along those lines. But we learned early on from these guys that it was also important to capture the qualitative things that they experienced. So essentially, we had helmet cams on everybody, and people were talking to each other after the fact, trying to capture the data also qualitatively of what did you experience, what did you see, what did you feel, how did things change when you did different operations. All those experience things that we get on the Fireground going to fires, we were trying to capture that as well during the experiments so that we can go back later and take the picture that the data paints for us as to where were the flows, where was the visibility, where was the heat, where was the energy, and marry that up to what they experienced as well so that we can try and begin to bridge the gap between experience and science. A big focus of these set of experiments was on the victim. And not that it hasn't been previously, but over the years, we've developed more measurements, better measurements, more accurate measurements, and we essentially put all that into this. There were several locations where we put what we call victim packages, which consisted of multiple temperature sensors, heat flux, which is also very important if you look at how much energy would be seen by a person. It's very important. Gas concentration. What could they possibly be breathing? There was a camera at each location, so we could see what could they be seeing. There was also our partners from the Illinois Fire Service Institute brought pig skin, which was 5 different samples were put at each location, looking at about as close as we can get to understanding how temperature and energy would impact the human skin. So there was essentially a water bath of 98.6 degrees behind 2 layers of skin with measurements throughout that, so we could see what would be experienced by a potential victim that would be in that location. Essentially, if a measurement could be made, or the science is there measurement-wise to take it, we put the best of the best in those locations to try and answer the fire service questions. We also had laser measurements looking at where is the steam going, and that was a measurement that we feel will be important for several reasons. One, to understand how much moisture is in the environment before fire department intervention, and then ultimately, whether it's an interior stream or an exterior stream, what does that mean to where the steam goes? I mean, we can understand scientifically and qualitatively as well, as these guys will tell you, that steam went different locations depending on the vent configurations, depending on stop and move, or continuous flow, or nozzle type and movement, and that's what we're looking to study, which is why getting to all these measurements and digging into the data is we're really looking forward to it, and we're getting into that right now. It's going to eat up a lot of our time. We also need to get the data in a format that we can pass it on to our technical panel, because we're going to give them all the raw data and all the raw video so they can analyze it themselves as well. Maybe they'll see something that we don't see, or maybe they'll see something that maybe is counterintuitive or doesn't make sense, and that'll help guide our analysis as well. I mean, there's millions and millions and millions of data points and all kinds of video that needs to be married together to make sense out of it, and unfortunately it's a process. I mean, we wish we could run some experiments and give the results within a week, and the fire service would have more knowledge to base their decisions on. It just doesn't happen that fast, but we will move as fast as we possibly can to get information out.
We're making it more efficient as we go along, not just the manual Microsoft Excel creates a graph was where we were at probably 3 years ago, and now we have computer programs that we've actually worked on our own that are going to analyze some of that for us and be able to make a little sense out of what's going on with the data, but not only that, but visualize it. So as we're starting to go through and have questions, we can kind of look at different sensors and see how our questions are answered. One of the things Steve didn't hit on, which I think was really interesting in this study, was we weren't looking at one type of attack. It wasn't just an interior attack. We looked a little bit at a transitional attack, some of the stuff we'd studied before. But it was more a thought process of where is the water coming from and how is it getting there? The initial parts of this study, which may not have been as interesting for firefighters, but really helped us guide how we were going to do some of these attacks, were looking at how much air is entrained by a nozzle and where water goes when you spray it into a room, whether you hit the ceiling with it, whether you hit the back wall with it, whether it's in a fog pattern. Are you doing a circular motion? Are you sweeping it back and forth across the ceiling? Where does that water go, and how does it affect the surfaces in the room? How does it affect the fuel that's potentially in there? And for extinguishment, and how much of it is, just laying on the floor after we're done with it. A lot of that early stuff went into developing some of the other tactics we try, because as researchers, we don't just get the opportunity to test what the fire service sees as the best practice, or what they see as second best practice, or what the West Coast thinks is best compared to what the East Coast thinks is best. We have the opportunity of testing things that we're not quite sure what the outcome is going to be, and that's the best part about research, is that we now have a tactic nobody may have thought of, but to see the effectiveness of that as we're comparing the two to each other. Just a really interesting part of this study.
Let's hear some questions, Bobby. What's going on out there in hashtag FE Talk land?
Great. Well, I've got a couple, and then I've got dozens that have been thrown at me for the last couple of weeks from all kinds of good folks. So one of the ones I think we can clear up right away comes from Mike D, and he says, will the test results be completed prior to the timelines set for the new NFPA fire attack standard? He's talking about 1700, and Steve and I can both talk to that. The NFPA standards, Mike, by design, move very slowly. And Stephen and Dan and Robin and Mike and Keith and Jack will certainly back me up on this. We're not finished with research. We're not even in the middle of the research. This is the beginning of the research. So I think that it'll be a long time before we see any guidelines or standards from 1710 or 1700 rather, and clearly as much data as possible will go into that analysis. Am I getting that right, Steve?
Yeah, it's a process, and I sit on 1700 as well as Dan Madrzykowski representing UL, and Dan was there last week attending the meeting that they had in Las Vegas, and it's in the early stages. A lot of it's being drafted. It's very methodically being put together. But if we think that any research is going to be done, I mean, I like to say that in the fire service, we're trying to make up for 200 years of firefighting without any research supporting it. We've got a long way to go to look at every aspect that goes into firefighting. But I think people will be pleased. I think it will be a good document that's going to tie a lot of things together. But it is still very much in the early stages of development.
We have another one also from Mike, and he asks about will the PMFA class rolled out after the earlier tests, will there be an update to the class with the new test results? Again, Mike, as an instructor, and I'll ask Robin and Steve and the gang to chime in on this, but any good instructor is constantly updating their material with new information. And so clearly, as these rounds of tests get analyzed and evaluated and conclusions are drawn, and some of which might conflict, and that's fine. I'm sure if you're every good instructor, including the PMFA, will update their material. But Steve, your thoughts, Robin, Mike?
We have a very good relationship with the International Society of Fire Service Instructors, and I think that we'll continue that relationship. We try and feed them the latest and greatest when it's available. As an example, I think they're looking to update their PMFA course, and they're actually hosting their meeting right up the street from our office in a couple weeks in order to make it convenient for us to go visit their meeting and answer the questions of their instructors, as well as feed them the latest information that we have available. Now, 2 weeks from now, we're not going to have anything as it pertains to the exterior fire attack project. What we will have is the positive pressure ventilation project is coming to an end. And Robin has done all of that analysis. The tech panel has done all the reviewing. The report is just about finished, and the tech panel is going to be going through the final review of the online training program here in the next week. So Robin will be sharing what came out of the positive pressure. Now, those experiments were completed a year ago. So, I mean, that's about the pace that this goes. I know ISFSI is paying close attention to the fire attack, and I know that they have their president, Steve Pegram, sits on the technical panel, so he has access to everything the other technical panel members have access to. And I know he is also very cognizant and very hesitant to get anything into that program that isn't ready for prime time. If we don't put it out, they will not put it out. So we try and stay in lockstep there.
And a challenge to all the instructors out there, our material, whether it be something Steve and myself are using in presentations, something Keith grabbed out of research, all of that information that we present at conferences, we get constant emails of, can I get that information? All of that's there to share to enhance your own training programs in your own departments, not just, us out there delivering our course information. There's tactics that are rooted in research that are now available for you to educate yourself on, and if you want to adopt them into your standard operating procedures or you want to get more information on them, it's always something we're interested in. So whether it's the PMFA class or you happen to be taking a class on slicers, happens to be the same organization, or even out in LA County with Chief Alconis has got great programs out there for his firefighters, they're all taking this information and putting it into a package that's easily deliverable. But there's nothing that says that that can't be done in your jurisdiction. So take the time to go through it. We're always there to answer questions. Our general email account, FSRI@ul.com, is constantly getting emails about what's your thoughts on this, or where can I find that information on positive pressure ventilation, or you guys did a study on horizontal ventilation. Is there a report out there for that? All those questions we answer all the time, and that's plenty of information to go through and develop those classes. And any good instructor, as Bobby said, is enhancing their curriculum as they go through.
We do our best. I mean, you see that Bobby mentioned our online training programs. We always essentially culminate every project with an online training program for a couple of reasons. One, we want one consistent message, and that if you just send a PowerPoint out with no information, it'll get twisted and turned and become whatever people want it to be. We put our stuff out narrated. We put our stuff out with a lot of care into the messaging, and we want people to have that reference to go back to. And it's free. It's easily gone through as a drill or things along those lines, and it's out there. And please, if you're going to use our information in your training, at least take the time to go and see what the original message was, and more importantly, what were the limitations, what was the scope. All of those things are very important to the message that you use outside of that program.
And I apologize. Apparently, Bill Gates and Microsoft kicked me off for an update to my computer while we were filming. So, and I was giving Robin a hard time for being a Mac guy. And he's like,
"We're still on, Bobby. I don't know." It's just...
I couldn't believe. I looked up and my computer was updating. I'm like, "What the heck?" So some of the questions that I've been asked, and if you guys wouldn't mind kind of addressing some of this stuff, kind of simple questions, but we had the houses were about 1,600 square foot, and so basically, if you could describe the process for how you got to that size, and then how you chose the attack methodology, and if you could just explain that a little to people. To those two styles, or why didn't they include this, or why didn't they include that? And I know it goes a lot to the scientific process, Steve and Robin, guys, if you could address that a little bit.
It does. It is very much, what we call variable control. So when we get our technical panel in the room for the first time, and we give them a little bit of background on what was funded, what we're looking to get out of the study, that comes from questions that we got from our advisory board, which is another level of fire service oversight that we have that Bobby is a member of, and Eric Roden is a member of as well. It starts with that. We get them all in the room, and of course, everybody wants a million questions answered. I mean, interior fire attack, exterior fire attack, everybody has 1,000 questions. And you start trying to break the problem down. It's like, well, there's unlimited amounts of structures, there's unlimited amounts of fuels, there's unlimited this, unlimited that. And we really need to start breaking it down, looking for middle grounds, looking at bounding problems, looking at limiting the number of variables. Because the important thing here is that if we just vary everything, we did 30 tests and we did 30 different structures with 30 different nozzles, with 30 different movements, with 30 different fuel loads. At the end of the day, we come away with nothing. Or at least a whole lot of interesting stuff, none of which can be compared, which pretty much what I'm describing is the Fireground. We go to 1 million fires a year, whatever the latest NFIRS number is, and we get a whole bunch of qualitative input as to what happened, why it happened, what was experienced, all of those things. We understand that's reality. Well, and then when you step back from reality for a second and you start to look at it and say, all right, well, what do we have? Well, we've got a ventilation and fire. All right, well, what does that mean? How much fuel do we need to create that condition? How much fuel is typically in a bedroom? Well, we go to everything from one-story houses to large apartment buildings to high-rises to schools to large houses, small houses. Okay. All right. How can we shoot the gut of this thing and look at what's going on here? And in the past, we've bounded the problem with a smaller, older-style ranch house and a larger open floor plan, break room, 2-story, 3,200 square foot flooring. Well, when we brought that to the tech panel and we looked at that, and if we do that, we look at 2 different structures, we split our variables in half. We split the amount of tests we can run at each structure in half. So right off the bat, we decided, you know what, we want to start I shouldn't say simple, we want to start consistent with a ranch house. And then we started looking, well, what size ranch house do you want? Do you want 3-bedroom, 4-bedroom, 1,200, 1,600? And we kind of went to the average square footage, kind of in the 1,600 square foot ranch house. And then the panel wanted a long hallway. They wanted something that was a little bit longer than what we had had in our structures in the past because they want to look at making that push down the hallway. What do we do to the flows in that hallway, making the way to the bedrooms that were on fire? Very understandable. Also allows us to give victim locations different exposures. Near the fire room, in an open bedroom, in a closed bedroom, at the end of the hallway, in the flow path, out of the flow path, which was all good. And then that allowed us to choose our structure, and then to help us understand what tactics we were going to use, one, we threw out a whole bunch of ideas for nozzles and flows and things along those lines, and we asked each of our panel members to go back to their departments and film themselves doing a particular evolution. In this case was we were trying to mimic fighting the fire in the ranch house. So we wanted them to advance, pull off the rig, mask up, stretch in through the front door, make a left or a right, advance down a hall, and put a fire out. And interestingly enough, what we got back was 2 predominant methods, which is where the shutdown and flow and the continuous flow came into play. So that allowed us to narrow that down, because again, we want to try and be consistent so we can learn things from test to test. Then we need to limit the nozzle, limit the flow. And this is where the technical panel was crucial in, they were realistic in, well, this is kind of a target flow rate. These are about the nozzles we would use. And we did some water mapping and air entrainment experiments to give them a little more information for them to make their educated decision. So we looked at the different airflow, and we saw that it was a little bit different between smoothbore and straight stream. So that caused them to say, well, then we need to look at both if it's different. Then we looked at different movements, O's, T's, Z's, upside down U's, continuous open, not continuous open. That gave us a little more information to begin to boil it down as to what really is that different. And that's pretty much the process we take. Then we look at instrumentation. What do we want to measure? And we use that to give that to the panel, let them digest that, and come back to us with where they want those victim locations and what what we might see different between them, and looking at egress paths out of the structure and things along those lines. Interior and exterior flows, all of that came into play. But as you'll see, as we come out of this, that there was no more than one thing to change per test, so that we always have something to compare and something to learn. Long-winded answer, but that's kind of the process.
So a follow-up to that, if someone wants to comment on this, we got from Doug Bledsoe, and Doug asks, heard questions from folks who weren't there, saw the videos, in reference to open windows versus quote-unquote real smoke fire behavior. Can you address? I think the point of the question would be, in some of the tests, Steve, we have the windows open to show either ventilation that had occurred or a window had failed, but can someone speak to that particular concern from Doug?
If I interpret that right, I think what I'm hearing is, maybe why did we start with the window open? That might be the question. And again, that gets into variable control. We've learned in the past that windows don't fail the same way, depending on the window construction, depending on double pane, single pane, wood, plastic, you name it. We did a study on that, so there's a background of what goes on. What we came to is what's really important. And what was important wasn't necessarily how the fire grew, but what the fire department arrived to. And we wanted that to be as consistent as possible. So instead of having varying window breakage times, things along those lines, we start the fire with a flaming ignition with plenty of fuel. We allow that fire to develop and go post-flashover, ventilation limited, and we want the fire department to arrive to, in this case, either a fire that was starved for oxygen with no vent, fire out of one window, or fire out of two windows. And having the windows open takes the variability out of play, gives us consistent fire growth, and allows us to have repeatable conditions that we're attacking that are representative of what would be found in reality. And you look at response times, you look at fire growth times, you look at fire dynamics. All of those things vary, and they're different for every single fire. And what we wanted to do here was, well, if we wanted the fire department to arrive to a particular condition at 15 minutes, then we would do a smoldering ignition in the chair that would transition to a flaming ignition that would go to a flashover. If we wanted to slow it down, we could put a flaming ignition in a wastebasket next to the chair that would catch the bed on fire that would go to fire out. We just went with a consistent flaming ignition, fire growth, fire under ventilated, and arrival. And in our analysis, we will explain why that's what that allows us to do analysis-wise, and understand the limitations that go with that as well for victim survivability and what the victims would be exposed to prior to fire department arrival, things along those lines.
It's an opportunity to gain insight into things that, as a fire service, we don't always have an opportunity to see. There's a lot of discussion from our tech panel about the growth of the fire and the smoke production from the windows, and what does the flame look like coming out the window, and how often on the Fireground do you get the opportunity to spend 30 seconds looking at that and analyzing what you're seeing in front of you. It's a great learning opportunity. Our fires had real fuel. They grew like a firewood that was connected with a flaming ignition in a chair. There's no controlling that growth. It is going to grow as the fire would grow based on laws of physics. Whether the window was open or window was closed may change that growth process at some point, but it's not going to change the way the smoke flows out the window, the way the flame comes out the window. So it's a great opportunity to learn a little bit about fire behavior and fire growth on how it is in a room that's ventilation that has a vent before you arrive. As Steve said, it was about bounding variables. If we want to compare a transitional attack or an exterior attack to an interior attack, we need to have the same fire 2 times. Well, we're not comparing an exterior attack to an interior attack. We're just putting 2 demonstrations out there. So Big thing about that was controlling that growth, and that's really what it led to. But I have seen those comments, Bobby, of the different growth and how that affected the fire, and that's one of those variables we really tried to control well.
Excellent, excellent answer. It makes perfect sense. But you can understand people having their questions. And another interesting question that's been come up many times, and we've got a few here, in talking about the several aspects of the skin test, the pig skin test, and I know Robin does a great presentation on victim survivability. There's if you have not read and taken the PPV training that the UL Firefighter Safety Research Institute has put out, you need to do that. Really interesting results there. But in regards to this round of tests, and in regards to the upcoming study on training props and methodology, several questions about the pigskin. First one was location. How is that determined? And it was interesting. One of the people mentioned to me, he said, Chief, we train our firefighters to do a right-hand or a left-hand search, but in my entire career, I've never found anybody in the left-hand corner of a building trying to find their way out of a fire, which I thought was kind of an interesting observation. So that was the first part of that question. The second part of that question was any preliminary thoughts that came out from it, just anecdotally, that you'd be willing to share. The third part of it has to do with what do you think the effects are going to be from that aspect of the study, and from what obviously Mike and Jack and Keith shared earlier about their observations are going to affect training, and then subsequently affect how we conduct a search and initial attack. I know it's a lot of stuff in there.
All right. Well, pigskin first. Why pigskin? I think the big thing there is that it's about, I think it's like a 6-month-old, 150-pound pig has skin that is as close to human skin as possible. And this comes from many other scientific studies that have been done over time looking at human skin. And it just so happens that the University of Illinois uses that on a regular basis in many other departments of the university. And working with Gavin Horn and his team, we were able to get samples of that. At first, we were thinking we were going to have to bring 150-pound pigs and put them in 6 locations in the structure, and how the heck we were going to get a semi full of pigs and all kinds of other stuff. And luckily, we were able to do a lot of background research and do some stuff in some ovens and introducing moisture and things like that, where we found that, well, we didn't need the whole pig. We needed sections of the pig and consistent locations taking the skin from it, and that we could actually simulate the backside of that skin using different polymers and different water baths and things along those lines. But I think the skin is the whole concept of the difference between air temperature, which we measure regularly, combining that with energy, and also duration. So it allows us to make measurements of temperatures in depth, which essentially allows us to understand how the cooking, pretty much how is the victim being exposed over time, how is that heat transferring to them and into them that is ultimately going to create serious injury. Is it going to give us absolute, no matter what, you're going to have 1st degree, 2nd degree, 3rd degree burns? It's not going to give us that. We're able to gain a lot from it visually, but that's another example of more data analysis needs to be done. All of those samples post-test were frozen. They will go back to the laboratory, and they will all be dissected and further analyzed to look at what we learned from damage. There isn't blood flow through the skin, but we try and simulate the best we can with the water being the right temperature on the backside. The sweating is different, but it's as close as we can get to learn as much as we possibly can about burns that an occupant could receive. There are also 5 per test, so that gives us lets us understand repeatability, let us get confidence in these measurements, and get a lot there. it's going to be interesting to see what it tells us.
So how did you determine the locations for the pigskin within these particular buildings?
So I was just going to answer that for you, Bobby. So the locations of the victims were picked two reasons. One, we were looking at can we generalize your exposure to a specific fire scenario. So in this instance, we looked at bedroom fires. None of our fires were kitchen fires or living room fires or dryer fires or anything like that. So if you happen to be in the room of origin, with a small degree of certainty, we could say that if you were in the room of origin and it went to flashover, that's pretty much it. So instead of putting a victim in there and burning it up every time, we decided that if you happen to be just outside the room of origin, which is where one of our locations was, what can we gain from your exposure time to a room that is approaching flashover, has gone past flashover, and now we're going to extinguish the fire? That also happened to be a victim that we put in between the hose stream and the fire. So what does that mean? Also right outside the fire room, so that if you're doing a exterior attack, what does it mean for that victim? So that's kind of that was our most crucial victim location. But from there, we needed to pick other locations where we could gain some insight from not just the exact point that victim was, but other points. So one of them was in the living room. It was just off of the attack crew coming into the living room. That gave us some insight as to what a victim would be like in the cool portion of a flow path when the front door gets opened. How are they exposed in that instance? Another location happened to be in the closed bedroom. We've done a lot of studies looking on the conditions in the closed bedroom, but now let's look at it from an exposure standpoint. So one in the closed bedroom, and if you're going to do that, compare one to it in the open bedroom, which was where one of the other victims was located. Both of those on a bed. You happen to be sleeping, you happen to be in the bedroom, that's a potential location. And then Steve said we had 5 samples. We actually had 5 samples at each of 5 locations. So the 5th location for us was remote from the fire. It was remote from the flow path. It was actually in the back corner of the kitchen, and see how that kind of affects, how the different attack methods affect that particular position, along with how does fire in a bedroom affect that particular position. But not only just those positions, but we recorded a lot of information about the environment around those positions. So the hope in the end is, as we go through this analysis, that if we can say if you were exposed to this temperature and this heat flux for this amount of time, you received a first-degree burn. Well, if we can, or close to it, or you had a 20% chance of a first-degree burn, or whatever our analysis comes out of it, we could also monitor those or have an idea of those conditions in other parts of the structures. So we could say with a moderate level of certainty, if you were in this location, because I know what the temperature was, because I know what the heat flux was, and because I know what the gas concentrations were, I have a relative understanding of the survivability potential in that particular location as it compares to another one. So it's not just picking a specific instance, but it's picking what we're measuring so we can use that later. Not just in data taken during these experiments, but data taken during other experiments or other types of measurements. Using pigskin in every fire test going forward is probably not going to be the most economical way, but if we could use this to develop other measurement techniques or other analysis techniques, it'll really allow us to go forward having a better understanding of victim survivability.
A big focus of the victim packages will be at fire department intervention that things get better, that things get worse. And that's, I mean, that gets away a little bit of were they dead? Were they dead? Are we sure they were dead? Because that's another issue we have. There's a lot of engineering analysis tools that exist to allow us to assess essentially what we would call tenability. So at what point is it reasonable to say that a person would be able to self-evacuate out of this environment, or are they most likely unconscious? In an engineering analysis, that's pretty much where it stops, because if you're designing buildings and people get to that point where they can't get themselves out, that's a failure of the fire protection systems. Ours is a little bit tougher, because now we're not looking at just tenability as to when do they become unconscious, but what areas are survivable. Because you care about when is someone no longer viable to be brought out alive. But we can step away from that a little bit and just purely look at this is where they were at when the fire department arrived, and it either got better or got worse from that person for X period of time. And we obviously want to look at what does it take to make it as much better for that person as possible.
Wow. That's perfect. That answered about half a dozen questions. That's great. I got so many other questions. One last one before I ask you a final question for the group. But one of the folks out there in Finland asked, how did you determine the countdown times for window and door openings and nozzle teams?
Sure. So for that, everything was based off of conditions. We picked at the beginning with the technical panel what we felt was a reasonable fire condition as well as a rough arrival and deployment time, and pretty much based it off of that. And then every experiment from that point on was based on temperatures and conditions in several locations within the structure. So we made sure that we were attacking, if there was a one-room fire with a vent opposite, that it was attacked, the same conditions were attacked every single time. It was a two-room with two vents, same conditions every time. So the moment the attack crew would open that door and begin their attack, would be based on conditions, not necessarily time.
Wow. Okay, so now, this is a fun question, and it's not a scientific question. I just want a gut answer, and then I've got my final question. So the gut question is, and I'm going to throw this out to Mike and Keith and Jack, of the shut and move versus the continuous flow. If you're out on the job with your company tonight or today, and you had a ranch home similar to what you were in, which methodology would you prefer?
I guess I'm going to go ahead and start with the answer of saying I'd probably plead the fifth.
It's a fair question. So having seen no data whatsoever and only qualitative.
No, yeah, absolutely. This is just purely anecdotal.
I would say that you have to start by looking, and at least we have the benefit of knowing the ventilation configuration prior to making our attack, but it's definitely, at least in my opinion, going to be dependent on whether or not I have a vent ahead of me, whether or not I have one room of fire versus two rooms of fire, or whether or not it's all buttoned up ahead of us. And I don't want to start speaking before I get my thoughts together in my head, but I feel like things are definitely different when you do not have a vent ahead of you. And I feel like the flow and move type of attack, where you keep the nozzle open the entire time, we'll see what the data shows, but from what I remember and from what Mike and I would talk about after the experiments, it felt as though that went a little bit smoother and a little bit easier for us, as we did have vents ahead of us. So that's one thing we'll have to see when the data comes out, whether or not that is actually held true by the numbers. But that's kind of one thing that I would hit on. My personal experience is doing search and rescue, so I'm looking at this from a little bit different perspective and seeing how I can take this back to my department and modify how we run our search and rescue operations and house fires. But let Mike hit on his experience.
I have to second just about everything Keith said. It seemed to be very dependent on ventilation configurations, whether it's ahead or not, two rooms of fire or not. From my vantage point, again, when we flowed and moved, I was right up with him, and was not really able to monitor conditions while we were moving down the hallway. But when I was able to stay at the hallway, at the start of the hallway, I did definitely notice differences, but they both worked. Both flow and move and shut down and move worked. But I would say the condition of the firefighter definitely seen that ventilation configuration was one of the major roles in how it felt for us.
But what I like about both those answers, and I'll just absolutely be blunt, is that it's so consistent with the training we've been trying to push out for the last 10 years about understanding the situation of the fire, the context of the fire, what ventilation you have, where's the fire location, how's it laid out, where's your wind direction. Those are also critical in determining the tactics you're going to use. and both of you showed exactly where I think old guys like myself had always hoped the fire service would go, towards being a thinking firefighter, not just a this is what I'm going to do every time. No, I'm going to evaluate conditions, and then I've got a wide variety of options available to me depending upon those conditions. So outstanding answers, and I think that's what the American Fire Service was hoping to hear, is that we've got men like Mike and Keith and Robin and Steve, the whole team. You guys are and gals that are involved in this are thinking firefighters, are evaluating the circumstances, are taking as much into account as you possibly can, but at the same time, you're so decidedly practical, which is so important, so encouraging. So my final question to all of you would be kind of an open question. Where is the UL Firefighter Safety Research Institute heading in the next round of studies? I know we're going to go training props and training. What are some of the broad overviews that you can share with the audience about that? And is there anything at FDIC that you'd like to throw out as special invitations to anybody listening today to come to your classes, or anything in particular you'd like to do? I'll throw it to y'all.
Thanks, Chief. Well, I mean, first off, thanks for the opportunity to share with your audience what we're doing. And big picture-wise, we've got the positive pressure ventilation study, which is coming out in the coming weeks. I'm not going to throw a date out because Robin will probably turn around and strangle me, but it's really close, and it'll be ready for prime time here pretty shortly. We've got the data analysis that we've got to do, but at the end of the data analysis, we've also committed ourselves to doing some acquired structure burns to support the fire tech project. So we're going to use our technical panel for everything we can, get one more series of experiments out of them. That'll probably happen early next year after we're able to digest what we've got already, to kind of take it from the lab to the street, if you will, and see what we can learn further. We've got our training fire project, which is getting going here, where we're trying to bridge the gap between essentially what you can do in a training building or in a training prop, whether it's concrete, metal, which is becoming pretty popular now, whether you do some sort of purpose-built or acquired structures. How do we bridge the learning that we need our firefighters to have when they get out the street, coming out of an academy or continuing education, when you can't exactly replicate with real furniture or real fuel what they're going to experience? And how do we make sure they learn the right things and apply it, even though they may not experience it quickly? So trying to match the reality there. The echo with you, Bobby. There we go. We're also got several other projects going on, looking at different things, working with partners, International Association of Fire Chiefs, looking at technology, and that. So a whole lot going on. Really looking forward to FDIC. That's really where our heads are at right now. Dan Madrzykowski has a workshop on Monday. I'll be with Gavin Horn and Denise Smith talking about the stuff we're doing with the Illinois Fire Service Institute on Tuesday for a workshop there, so please sign up for that. We know a lot of our advisory board is led by Sean Gray, doing some interesting hands-on training stuff as well. So we'd like to plug that as well. Robin's got a couple of classes. I've got a couple of classes. All be there. One of the biggest things we look forward to at FDIC is not the teaching, but the learning. We're going to I know I'm going through the schedule, trying to make sure I can go to as many classes as possible and see what the latest and greatest is out there, because our future grants of questions we want to answer is going to come from the fire service. And in order for us to pick those topics right, we've got to understand what the latest and greatest is that's out there. And the best place to see the latest and greatest is at FDIC.
And don't forget, Thursday we're going to have a webcast with Stephen and Denise and Gavin talking about the UL Illinois Fire Service Institute Skidmore work that they did down at the Illinois Fire Institute. So we'll be talking about the physiological carcinogenic studies that Stephen was part of. That'll be next Thursday, a live webcast, absolutely free here at Fire Engineering.
Absolutely, looking forward to that, and I mean that's another perfect example. I mean, here's experiments that were run in June, and we're still in the early stages of analyzing the data. Some of that medical data takes like months to process, so it's almost like every day we're learning something new in that project. So we look forward to sharing the latest and greatest next week.
Well, Stephen and Keith and Robin, Jack, Mike, thank you so much for spending some time with us today. I know you guys are extremely busy and you're doing incredible work. Hope to see you all at FDIC. Again, I'd just like to express my personal gratitude, but also the Fire Service's gratitude for your hard work and your dedication and everything that you're doing for the Fire Service and for firefighters. And again, folks, if you have not been to the UL Firefighter Safety Research Institute website, please Google it, go there, take advantage of all the great training and education that's on there. We look forward to seeing everybody at FDIC. Until next time, thank you so much for joining with us, and remember, please be careful out there.